All right, so this is going to be the geometry, and it is Unit 4. No, Unit 3, I'm sorry. Unit 3 Transformation Review. All right, so you guys already have yours done, right?
Yes.
Okay, good. All right, so now for this right here, we're going to take a look at this and try to solve it. So now, like I said, told you guys already before, you could use your handy dandy. If your handy dandy has these rules in there, you could use that on your test. So part of the things that you're going to have to make sure is all these things need to be in there. So first thing, point W of quadrilateral here is -2, 2. What is the image after of W after using transformation? Okay. After using the transformation, did I forget to copy something on there?
Yeah.
Oh, it cut off the thing, right? Okay, so it cut off the rule. So the transformation is supposed to be, let's see what I got here. So the transformation was x comma y, and it was moving it to I'm sorry,
It's,
x minus 2, right?
yeah.
Y plus
minus
3.
2, y minus 3.
There you go. All right, okay, so now, after that transformation, so that means I'm doing what to my x value?
You're going to subtract 2.
Subtract 2, so -2 minus 2?
Negative 4.
So W prime is going to be at -4. Now, for the y values, it's going to be 2 plus 3, which gives me?
5.
Bam, there we go. All right, so now in words, Matthew, in words, please tell me what I actually did. Okay, but in words, remember we're doing it on a graph. If you're thinking about it on a graph, what would this transformation be? What does this mean? What does the x minus 2 mean?
You're subtracting
to the left.
Okay, to the left, yes. That's what I mean. So I need those words.
On the x, you're subtracting to the left.
Not subtracting to the left, you're moving to the left, right? Okay, so it means 2 to the left.
Oh, 2 to the left and 3 up.
Very good, that's what I'm looking for. Okay, so that's how we can actually do it. 2 left, 3 up. This is one way of actually doing this and actually getting me at the right spot all the time. So doing the explanations, you can get away with this as an explanation. All right, so let's take a look at the next problem then. All right, given triangles located there, hopefully I did not mess up this one again. Okay, at those coordinates, what are the coordinates of the triangle after 90 degrees counterclockwise about the origin? Now, what is the rule for that one? So it's going to be x comma y. And so 90 degrees counterclockwise. What is the rule for 90 degrees counterclockwise?
Negative y.
Negative y.
Positive x. Or the regular x, sorry.
Just x, right? You guys all agree? Okay. If you have the rules, all this is going to be very, very easy. Okay? So that means that my W is going to become, so it's going to be opposite of my y value. So if my y value is -2, -2, and -2, very good. The x value,
-3, positive 3.
is it positive 3? -3, because it doesn't change, does it? Okay, and y?
-4.
And positive 1. Okay, so coordinate rule. That's what I was looking for here. X comma y. It's going to be my -y comma x. That's what we're looking for. So, in your notebook, you should have these rules, right? So I'm basically giving you answers for the test if you have them in your handy dandy notebook.
So you're basically saying we can write all this in a handy dandy.
Bruh, for like a week I've been telling you write down these rules.
Okay.
Thank you. Alright, so let's take a look at this. So given this is what we have. So right here we're rotating 90 degrees clockwise about the point negative 1, 1. Okay, so this one is slightly difficult because it's rotating not around the origin. Not around the origin. So that means that if I use patty paper, it's going to help me out a lot. Now, what I don't like is the graphs on these. These graphs, if you look at the increments, what are the increments here?
2.
They're all 2s. So it kind of messes you up there, right? So negative 1, 1 is right here. So it's left 1, up 1. So I have right here. So using my patty paper, I have to rotate it around that point right there. Okay, so everyone right now, patty paper, please, please, please. Okay, try that. So you only can do it on patty paper. I can't even do it on the board for this one right here because I can't rotate it around non-points, non-origins.
No, you can also do it on the calculator.
Yes, but that's this year I'm actually not teaching it by that. Okay, so using your patty paper, if you do rotate it around that, so instead of putting your axes right there, yes. Instead of putting your axes right there, you put your axes on negative 1, 1. So if I rotate that one clockwise 90 degrees, so instead of rotating it using the axis, I'm going to use it just at that point. So make sure you mark which way is up, just like you do normally with your patty paper. So clockwise. So I did it on my paper. I can't show it on the thing here, but I will show my end result. So as I rotate this thing around, it's going to come up to right here. My next point is going to be right here. And my last point is going to be right here. So here's my L prime. This is my K prime. This one right here is my J prime. Okay, so my points are going to be J. Now, like I said, the increments are in 2, so that messes you up here. So you have to make sure you count it. So that means it's going to be to the right 1 and up 0. Okay, K prime is going to be right 2 and down 4. So it's 2, negative 4. And L is going to be left 3, down 5. So it's 2, 4, 5. Like that. So that should be the answer for that one. So that's going to be one of those weird ones. So hopefully if you do it with patty paper, you can do it correctly there. So, all right, so let's take a look at right here. What are the endpoints of the image if it's reflected over the line? Now, what line is this? Someone over here, please turn your phone off. I'm getting tired of hearing that. Okay, what line is this? I heard it. Y equals X. Dora, is that your alarm going off?
He's watching the movie.
I know. Okay. Got to catch up on Stranger Things too.
Honestly, same.
Now, so this is Y equals X, right? If it's Y equals X, what's the rule for Y equals X? X comma Y changes to what?
Y, X. Just Y and X.
Just Y and X?
Yes.
Like that?
Yes.
Okay. Just Y and X. Okay, so now let's take a look. So this coordinate right here, so A is at 2, and that's -3. B is at 4, -2, 4, 6, 7. Yes? Maybe? Okay. All right, so now on this one right here. So I have the rule for this one now. So my rule is going to be that A prime is going to be located at where? Come on, you guys. -3 and it's not that hard. Everyone just like fall asleep right there on that one? Okay, Josue, you get this one. You ready, B prime? B is there, the rule is there, just tell me the answer. Alright, can someone help him out? Go ahead. -7 and 2. That's what the rule is. We're just changing the X's and Y's. This rule should be in your notebook. That's all it is. So, A prime, -3, 2. And -7, 2, 4, 6, 7. Wait, this is the wrong way. -3, 2, right? -7, and then 2.
Isn't it supposed to be at?
Looks right. Wait, 2, 4. X value should be 4. That's what's wrong. That's what's wrong. Where were you at on that one, Jose? That one's supposed to be, so B, I messed up that one. That one should be 4. There we go. So sorry about that. Is that what was confusing you, Josue? There we go. Okay, so now we get it better. -7, 4. Right here. So there's my B prime.
So you have to write that, the coordinates and everything?
What are the endpoints of the image if it's reflected about that line? So we have this. We also have a graph. So if you wanted to try and do it on patty paper, you can. Or you could just use the rule, which should be in your notebook anyway. All right, let's take a look what we got here. Stephanie wanted to translate a triangle with vertices. Now, write down those vertices. So 4, -1. 1, 2, 3, 4, -1. B is 3, -3. 3, -3. -1, -1. Okay, so we got that one. She graphed the image of triangle. All right, so A, so it's -1, 3. So -1, 3. 1, 2, 3. B is at -2, 2. -2, 2. And C is at -6, 3. 1, 2, 3, 4, 5, 6, 3. All right, so there you go. So for this one right here, it says part A, graph the two triangles. If you graph it, you get at least 1 point. Hopefully you graph it correctly. Okay, did she graph the translation correctly? No. Okay, no. Okay. No, so this is translation. So let's take a look. What is my translation supposed to be? So if I do A's, so for A's, my translation would be X, comma, Y, and it would be X. Now I'm moving to which way? X. X is left and right, isn't it? So it's going to be 1, 2, 3, 4, 5. And up 1, 2, 3, 4. So that's going to be left 5, y plus 4, right? Yes? Okay, so let's do the same thing for B. So B is supposed to be X. Now, if I count it over from my X's, 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. So that's going to be left 5 minus 5 and y plus 5. And C is X comma Y is moving to left 1, 2, 3, 4, 5, up 1, 2, 3, 4. So again, left 5, so it's X minus 5 and Y plus 4. So one of these things is not like the other. One of these things is wrong. So we did the translations, right? But which one of those is wrong?
B.
B, because it's not the same, right? So if she didn't, what will we change to fix her mistake? So B should be what? Y plus 4, right? So B should be X comma Y is changing to X minus 5, Y plus 4. And what is the B prime coordinate supposed to be?
3, 1.
So B prime coordinate?
No, 2, 1.
So it's supposed to be -2,
No, 2, yeah.
1. There you go. So -2 and +1. Make sense? Okay. All right, so let's take a look at the next one. Okay, refer to the figure below. State the number of line symmetry. Do we have line symmetry here?
Yes.
Yes.
Yes. Adonde? Where?
Straight down.
Across it.
Straight down? I heard it straight down.
Also across it.
Across it? Where?
Like,
Cutting it in half.
yeah, cutting it.
Okay, where?
Like,
Around,
of the two, but
in the middle of the two.
In the middle of the two, right here?
No, not
above.
above the two a little bit.
Right here?
No.
In between the two and the,
Oh, in between those two, right?
yeah.
So if it goes up 1, 2, 3, 4, 5, half of 5 is 2.5. So it should be right here. There we go, right? So you should have those two lines symmetry, right?
Yep.
Okay.
Wait, can you? Isn't there another one?
Where?
Diagonal.
Now, if you do a diagonal and you fold it, where is this one going to end up at? It's going to end up over here, isn't it?
Oh yeah.
So it's not going to be symmetrical if you cut it this way,
Okay.
okay? Because it's got to be the same on both left and right. Yes, it will be equivalent to the same, but we'd have to rotate the piece around for it to be the same. So we only get those. So I get 2 here. Now let's see if this works. Let's see if I could actually do this. Okay, number of line symmetry. Now let's try a rotation on this one. I've been wanting to try this one. Ooh, okay, I'm gonna try a rotation here. So now I'm gonna try and figure out the order on this one. The order of rotation. Okay, that's when we try and figure out the degrees, right? Okay, so now if I were to do this, it would go, what do you want to go? Let's rotate counterclockwise just because. Is that the same as my original?
No.
No? Is that the same as the original?
Yeah.
That one would be, right? You're just looking at the shape, you're not looking at the graph. So we're just looking at the shape. That one would be the same as the original, right? So that's 1. Is that one the same?
No.
And then,
Yes.
so what number would I use?
2 over
360
360
degrees
or
over
90.
2.
There we go. So I would do 2, right? That's what I was looking for there. So my order is 360 degrees divided by 2, which is
Is that 90? 180?
180 degrees. So it has 180 degrees rotational symmetry. Okay, so now let's take a look at this. We're going to do the same thing with this one right here. Okay, all right. Now let's take a look at this one right here. What is the smallest angle of rotation that maps it onto itself? Okay, so you guys got some letters on yours, right?
Yeah.
Yeah.
Okay, so since we got some letters on yours, let's take a look here.
The first
So I'm going to, let's see if this works
the
right.
tip is A.
This one's A. Okay, so we got that. So now let's try this one right here, okay? So every time it goes back up to here, that would be what? That would be 1 from our rotation, wouldn't it?
Yeah.
Okay, so let's try this. There we go. All right, so we're gonna try this. So now we're gonna rotate and let's do clockwise, okay? Because over here we need clockwise anyway. All right, so we're gonna rotate clockwise. So that's gonna be 1,
2,
2,
3,
3,
4,
4, and
5.
5. Back up to the beginning. Sorry, I'm just not very good at.
Accuracy.
I know these shapes. The pentagons are like so hard to draw. Okay. There we go. So we came up with 5, right?
Yeah.
So now for my order, I would do 360 degrees divided by 5, which gives me,
72.
so smallest is 72, right? So this is, let's do the letters. A, what was this?
E.
B?
E.
E? What's this?
D.
D?
Yes. C.
C.
B.
Like this?
Yeah.
Okay. All right, since we're rotating clockwise, okay, so to go from A to E clockwise, we're going this way from here to here, how much is going to have to rotate?
72 degrees.
72. Why 72?
Because that's.
That's each time from every point it's 72 degrees, right? So this first one is 72. Okay, now from A to D. So if it's going from here all the way over to here, how many am I moving?
To where?
From A to D.
That's
22.
Oh, that's
144.
Double.
40. That's 140.
Very good. 144. Because that's double, isn't it?
Yeah.
That's two of them. Okay, I'm moving two of these, so it's 144, right?
Yep.
Okay, so now A to C.
216.
216. Where do we get 216?
You triple it.
So it's my 72 times
3.
3, because I'm moving past 3 of these. A to B.
3. No, 288.
And A to A.
360.
360 to go all the way back to the beginning. Yes? Okay. All right, it's almost like we did this exact same problem, recently. Identify a single transformation that is equivalent to reflecting the figure across line N and then reflecting across image line M. Okay, so let's reflect this. Let's see if I can do this one. And I know I have an option for it here. Okay, and I will transform, and let's there we go. So there we go right here. So there is my reflection across that, right? Now, if I reflect this one here, what's going to happen to it now?
Good.
Same one, right? Same thing. So I'm going to reflect that one. Ah. Uh-oh. I lost my middle one. So it should look a whole lot like this when I'm done. Okay? Because this one I reflected once and then I reflected this. Now, so what is the same as reflecting against parallel lines?
Translation.
It's a translation. It's a slide, right? That is my translation. So I'm going to write that for my answer. Explanation, because you are reflecting across parallel lines. So it's the exact same thing you guys had to write on your notes when we're doing this.
Oh, I'm going home.
Let's try and finish up that last one. Or actually, next one. We're not going to finish them all. All right, so what number? I kind of lost track. What number were we at? 9.
9.
9!
Why?
Yep, I went there.
I know.
All right, so for this right here, what transformation or composition of transformations is the same as two reflections across perpendicular lines? Now, it's almost like, again, excuse me, Chris, I want to talk over you. All right, so it's the same thing that we had in the notes. Okay, so right here, if it's reflected across perpendicular lines, it's the same as what? I heard it. Rotation. Rotation, how much? 180. There it is. So rotation. (180 degrees). So just sketch something. So let's say for instance I did this one. I called this one, I think I called it T, right? It's like the same as what we had in the notes. That was T. So now this one over here became T prime, and then reflected across here. And this one here became T double prime.
Other one becomes 3 T triple prime.
Yes. Make sense? That's basically all we have to do for this. Questions, concerns, complaints? We are going to finish this on Monday, so we plan on taking the test on Tuesday. Tuesday. All right. So we will finish this up Monday. So please, if you did not finish the review packet, please make sure you do go over it.